Hi, my name is Babar and I am a research fellow at the Center of Wireless Innovation in Queen's University Belfast. 5G new radio standards are now set and deployment is on its way. Extensive research have shown that MIMO can meet the high data rate demands of mobile users. Many scenarios have already been tested, but we are still facing at least 3 major challenges in optimizing millimeter wave massive MIMO solutions. The first challenge is that in millimeter wave frequencies, the electromagnetic wave will face huge losses while propagating through free space. Also, when talking about multiple antennas sharing the same space, the mutual coupling effect may degrade the antenna efficiency. In my research, I therefore propose a 2-stage Rotman lens-based beamformer as an RF front-end solution for hybrid millimeter wave MIMO base stations. This solution attempts to find the best trade-off between cost, complexity, and performance. The uniform rectangular array formation solves the first challenge by adding the array gain to mitigate the path loss. Second challenge: to add steering capability in a beamforming, we require a network of phase shifters and power dividers, which are lossy and expensive in millimeter wave frequencies. This multiple-stage lens solves challenge number 2. The Rotman lens principle in my 2-stage architecture provide the functionality of phase shifter and power combiner at the same time that removes the requirement of lossy phase shifters for the beam steering to happen. Finally, challenge number 3. The theoretical principle of MIMO require each antenna to be connected separately to the baseband processing unit, making the overall system cost too high, especially when we talk about 64 or 128 element MIMO systems. The number of RF chains supported by this beamformer are less than the number of antennas. Such a misbalance leads to massive hardware reduction while keeping the MIMO operation intact. With this low noise amplifier and mixer circuit, this design represents a full end-to-end millimeter wave hardware all the way from antennas to the signal processing unit. And the basic requirements considered in developing this solution are in line with the ITU requirements for millimeter wave 5G. Using this module in one specific sector of cell of 100 meter radius, we can get 1.4 gigabits per second per user. This system represents a brick for the architecture of future wireless system, because unlike existing solutions that require dedicated RF chain per antenna, my approach massively reduces the complexity and the cost of millimeter wave MIMO RF front end in 5G mobile networks.